Okay. So most of human history, okay, this stuff that we're learning about now, this only happened 500 years ago, which is not that long ago in terms of history. And the medieval view, throughout the bulk of human history, people viewed the universe this way. They got their knowledge mostly from the Bible or from ancient Greek and Roman scholars who they believed had done the best work that could be done. So people like Galen and Ptolemy and these ancient scientists, mathematicians, and doctors, they thought no one could ever do better at science than them. So they just would continue going with those beliefs. And those beliefs gave us the geocentric theory, and that's what's pictured in the picture. Geo, Earth at the center. And they couldn't account for why the stars didn't fall unless they're stuck in something solid. And back then, the medieval person was a little bit intellectually insecure. They were pretty sure that all the best thinking had already been done. And the best way to learn things, if we go back to the warm-up, was to go and look up what the smarter people that lived before thought. And so they think almost all knowledge has already been gathered. We just need to look it up. That's how we learn, is by researching in books. The scientific revolution changes that to the mindset that we have now. Okay, so we get a new way of thinking. Part of that starts in the Renaissance. You read a little bit about the Renaissance in prologue section 2 as it related to democracy. But think of those ideas that you looked at from the Renaissance, you know, the value of the individual, the unlimited potential, right? You had to answer that question about how explorers and merchants and bankers and all sorts of professionals expressed themselves during the Renaissance, right? Which is very funny to Emily Martinez. So this new way of thinking begins to spread outside of where the Renaissance was in Italy. And people start thinking, wait, maybe there is new stuff to be learned. One of the things that convinces them that there's new stuff to be learned is they learn some more old stuff. All right. They discover more ancient manuscripts and things from the past, and new ways. They become experts in ancient languages and reinterpret what they already knew. And then they're going to combine that with a radical new idea, right? Which the vast majority of you agree with, and that is learning by experience, by observation. All right, if you want the answer to something, go look at it. That seems obvious to us, but this was a new way of getting information back then. I have a question. I want to find out the answer. I'm going to do an experiment, and I'm going to observe it. I'm going to write down what I see. In addition, right, this is the time where, and you studied it in middle school, we don't really go over it now, but you have Christopher Columbus, you have Ferdinand Magellan, you have Amerigo Vespucci, you have Europeans traveling all over and finding new parts of the world that they didn't know were there. And this opens up new avenues in science and thought. So it's a time of a big change in how people think. And we call it a revolution because it's not bloody. Okay, the revolution we're going to have in a little bit, in a few weeks, is extremely bloody. But this is just a revolution because it's a fundamental change in the way people think and behave. That's what we mean when we say revolution. So revolutions don't always have to be violent and bloody, although they often are. All right, so this is a revolution. And we're going to see new discoveries in astronomy, mathematics, and I'll talk a little bit more about that stuff in a minute. One of the key changes is we get rid of that geocentric view, which had been held for most of human history. And a Polish priest named Nicholas Copernicus says that's not the way things really are. It's not geocentric, it's heliocentric. The sun is in the middle and the planets revolve around the sun. So that's the heliocentric theory. That's what you learned today in school. So Copernicus was a Catholic priest, and he was very worried that the church wouldn't like this new theory about how the universe was laid out because it doesn't put the earth at the center. All right, from from the standpoint of Christianity, there's one main story, and that is God creating man, man screwing up, and man working to be better. And the Earth needs to be center stage for that story. So there's other planets and other galaxies that kind of throws things into a new perspective. So Copernicus was worried the church would condemn his work. So he did two really smart things. One, he dedicated his book to the Pope, his ultimate boss as a priest. And two, he waited until he was sick and about to die before he published his book. So if there was trouble, he wouldn't be around to have to deal with it. So Copernicus publishes his heliocentric theory that has the sun at the center of the solar system, but by extension, they really viewed the solar system as the center of the universe, which was spread out from there. And besides putting the sun at the center, Copernicus got nothing else right. His model actually was not as useful as the ancient models of Ptolemy and Aristotle for navigation and predicting, because he got the shape of the motion wrong. Because he was still a priest and he still believed that space had to be according to some divine plan, he believed that the planets had to go around the sun in perfect circles, which they don't. They go in smushed circles called ellipses. And it's going to be later astronomers like Johannes Kepler that will fix that part of his theory and get an accurate model for the solar system. All right. And so Kepler is going to adjust it and make the system work for Copernicus. And then we get someone you may have heard of already, an Italian, very much a bridge between like the Renaissance and the scientific revolution, Galileo Galilei. And he's kind of like a Da Vinci, multi-talented genius guy. And he invents one of the two new types of modern telescopes. There's refracting and reflecting. And he invents the refracting telescope, and that allows him to see the stars and the planets with much more detail than you can with the naked eye. And as he can look at space and things in space in more detail, he starts to look at things that make him question, how can all the things up in the sky be stuck in this crystal and these things happen? Like, for one thing, the moon's really bumpy. There's big marks all over the moon from where things have hit it in the past. So if the moon was stuck in solid crystal, how could something hit it? And then he also sees other moons around Jupiter. So if Jupiter is stuck in crystal, how could other moons be moving around it if everything is solid? And so he begins to postulate that not only is the heliocentric theory correct, but that space is vast, much, much bigger than anyone had previously thought, and that it's empty. It's mostly empty. And so this is going to blow people's minds. And the church doesn't want people's minds blown. And so they don't attack Galileo's work at first. They essentially say to Galileo, hey, go ahead, do your research, but don't tell everybody about it. Because the average person, they're not going to understand it, and it'll cause them to lose faith. Us smart people can debate it and talk about it, but if you let everybody know, you're going to hurt people's faith, so don't do that. But Galileo, being a big fan of Galileo, publishes his work. And then the Pope calls him to Rome and says, you're going to have to denounce all of your work. You're going to have to say it was all wrong and you're just kidding. And Galileo says, well, no, I'm not going to do that. And the Pope says, well, okay, then we're going to torture you until you change your mind. And Galileo quickly changes his mind and says, oh, yeah, just kidding, JK about all that stuff. So he recants his work, even though he knows it's correct. He had, before the church got him, he had smuggled out a bunch of his work to the Netherlands where it could be freely published. And even though he does ultimately denounce his own research, he's forced to live under house arrest for the rest of his life so the church can keep an eye on him. But don't worry, in 1996, the Catholic Church apologized for the whole Galileo misunderstanding, so it's all good now. So, new discoveries about the heavens. What about any question, not about stars? What about if we have a question about anything? How are we going to answer it? Well, at this time is invented what you guys hopefully learned about in middle school science or last year, and that is the scientific method. Here's where it comes from. essentially what I've been talking about leads to this revolutionary new way of gathering new knowledge. Believing that new knowledge is possible was even a revolutionary thought. So, scientific method, as hopefully you learned, it's just a series of steps for answering a question. All right, and then so you'll pose a question and you'll start to think of possible answers, and you need to determine the right one. That's where we get to two more geniuses, Francis Bacon and Rene Descartes. And Descartes we previewed a little bit last week. Remember, he invented analytical geometry. So Bacon and Descartes, they don't work together, but later scientists take Descartes' work and Bacon's work and put it together to make the scientific method. What Bacon says is, if you have an idea and you have a question, go ahead and do an experiment. Try things out, try different things out and observe them and record what you see. That's inductive reasoning. You're bringing in new information and using that to help you answer the question. Descartes is the opposite. Descartes says you have a brain, therefore you exist, and that your brain is capable of great thinking and knowing great truth. So what Descartes says is, start with a question and remove every possible wrong answer. So if I have a question and I get rid of all the wrong answers, what am I left with? I got rid of all the wrong answers. What do I have in front of me? What if I lost my keys, or let's say I lost my phone, and I rule out every single place where it cannot be? What am I left with? Am I going to find my phone? Yes, thank you, Efren. Yeah, if you rule out every wrong answer, you have the right answer. And that's deductive reasoning. So basically, the scientific method is you start with a question, then you use Descartes' deductive reasoning to eliminate anything you obviously know is not the answer. And then you'll have a handful of maybe right answers left over. That's when you use Bacon's method of doing experiments to determine which of these answers is the rightest. And that gives us the scientific method. And then we get the 400-pound gorilla of the scientific revolution. He's really going to bridge us from the scientific revolution into the Enlightenment. And he's the most famous scientist outside of Albert Einstein, who we'll look at next semester. And that's Isaac Newton. He's an Englishman, full-time scientist. And he is going to do extensive studies. He's going to invent the reflecting telescope, which is even more powerful than Galileo's refracting telescope. And he's going to be able to look at the stars in the heavens even more closely, and he watches the things move around. And he agrees with Galileo that space is empty. But he's going to go a step further and try to explain, if space is empty, why are these things moving the way that they're moving, and why don't they fall on us? And he comes up with a force, and he gives us what's called a unified theory. And that is, and we don't have one of these right now. That's a theory that explains everything, a unified theory. And so his unified theory says there's this one force in the universe that explains all of it. And that's universal gravitation. Okay? And what creates gravity? Everything. Anything with mass creates gravity. So you and I create a little gravity. I probably create more gravity than you do. But we create a little gravity. But we're next to something extremely massive that creates a huge amount of gravity. And it's right below your feet. The planet Earth. So our planet is very massive. And what that means is that its mass bends the space around it. Okay, space is actually warped around Earth and other massive things. And he says that this mass causes objects to be attracted to each other. If everything has its own gravity, it's pulling towards each other. And he really answers the question, why don't things fall on us? Well, they are falling on us, especially if you look at the moon. The moon is constantly falling towards the Earth, but the space around the Earth is warped And so the moon falls around it and around it and around it. Okay. This blows people's minds as well. And then Newton, he's a very religious man personally, but he starts to come up with this metaphor for the universe that other less religious people are going to cling to. And basically the most intricate, cool, expensive thing you could have in your house if you were really rich back then was a clock. And I should have put up some pictures, I still didn't do it, of clocks of this time period. And they're made of brass and gold and silver, and they're under a glass dome, and they want you to be able to see inside so you can see all the gears and stuff working. Clocks used to have to be mechanical. We didn't have quartz-based electronic clocks like we do now. And so they're all based on gears and springs and tension, and so they're incredibly complicated. And Newton basically said, look, the universe is a giant clock, and God made the clock. And other people called deists, they'll go on with that, and they'll say, yes, the universe is a clock, God made the clock, but then God wound up the clock and it runs on its own, and God's not really involved in the day-to-day workings here on Earth. He made it, there is a creator, but he's off working on other projects now. All right. That wasn't Newton's view. Newton was again, very religious. But the deists, some of whom we're going to look at next week, believe that there is a divine force, but it doesn't really mess with us in our day-to-day lives. To get better theories, we need better information, and better information can come from better scientific instruments. Right? So new things like the microscope, like the telescope, but for seeing inside very small things, and that's going to be just as mind-blowing for us. The barometer measures air pressure, and it allows us some ability now to predict the weather. The thermometer, we know what that is. Right? So you're going to get familiar with this when we come back to school, right? We're all going to daily visit a thermometer. And then when you get new instruments, you get better observations, you get better raw data, you get better science, you get better theories and discoveries. So it feeds on itself. And it's going to spread through all different sorts of disciplines. So we'll go from physics and astronomy to biology. So people became very curious about how the human body worked. And much in the school of Francis Bacon, the best way to figure out how the body works is do what? Let's cut some open and see what's going on inside. So Andreas Vesalius, who was a Dutch scientist, he greatly expands our knowledge of anatomy and creates the first modern anatomy textbooks, looking at how all the muscles connect, how the vascular system connects, all of that. And so we get a much better idea of what's going on the inside by opening a few people up after they're dead. And then a little later, we get Edward Jenner, a British, he's sort of like a veterinarian / scientist. And smallpox was killing a lot of their cattle. And smallpox is a very deadly disease if you don't have an immunity to it, much deadlier than COVID. But what Jenner realizes is that his cows would get these, and this is gross, but they would get these big sores on the outside. And if he took the material out of those sores and refined it a little and injected it into people, they would develop a response, an immunal response, or a resistance to the smallpox virus. And so that's the first vaccine, right? And what are we talking about on the news every day today? A vaccine for COVID. When will it be here? Will it work? Do we trust it? But that goes all the way back to Edward Jenner, where he comes up with a smallpox vaccine. And then we get modern chemistry. Now, the medieval stuff like Merlin and stuff and changing lead into gold and potions and all that, that's called alchemy. The modern version of that is chemistry, and it's governed by the same scientific laws that govern Newton's universe. And the Scottish scientist, Robert Boyle, says, look, things aren't actually solid, okay? Your Chromebook isn't actually a solid thing, all right? Your bed, your walls, they're a bunch of tiny, tiny, tiny particles, and actually there's more space between the particles than there is solidness. So things are mostly not solid. Like space itself, things are mostly empty. And again, this kind of blows people's minds. And he proves it by working with gases And he says everything has three states, right? There's the solid, there's the liquid, and there's the gas. And since then we've added plasma, but this is not a science class. And so he says a gas is actually a thing. Okay, it seems like there's nothing there, like it's just space between me and my webcam, but there's all this air. And he says that air is a bunch of little particles, and it will behave accordingly if you manipulate it. So if you put gas under pressure, it gives off heat. If you expand it again, it sucks out heat. And basically he says, you know, that then as something heats up, the volume increases. Well, if air was nothing, its volume couldn't increase. So he comes up with the modern understanding of the three states of matter, and the behavior of gases and things like that. All right, and that's the notes. Let's take a look at the guided reading.